Okay, g'day. Welcome back. I'm actually starting a new playlist today, which I'm calling Chess Engine Tuning. You'll have noticed an earlier video, I did much the same thing. In the video, You Shall Not En Passant, I just filled around with the stockfish code a little bit to see what would happen if you disabled the en passant capability of a chess engine and see what impact that had on the strength of the engine. So at the same time, we were able to sort of do a little of dive into the stockfish C++ code, and that's a good learning experience if you want to work a bit more on these things yourself. Now, I'm doing a second video on the same theme now, except now what we're looking at is the quiescent search, which different engines have. I think the quiescent search is fairly well understood, is that when you get to the final position in the search tree you want to evaluate, you just make sure it's kind of a stable position. You follow all the checks and captures and come to a position where there are no more checks and captures, and then you do the evaluation, because then you know you're not halfway through a sequence of exchanges when you do the valuation. So the reason I want to look at the quiescent search is that in my recent video in chess stats about the sort of strength of world chess champions, I couldn't duplicate the results which the paper I was following came up with. And I thought one of the reasons for that is the quiescent search. Since that paper was done, engines have developed, and I think quiescent search is one of the things they've added. So in the old days, you did a search to 10 ply, it would be a search to 10 ply. But now you do a search to 10 ply, it's probably a search to 10 ply plus a few more ply on top of that. So what I needed to do was adjust for that to try and work out the complexity of the position without this sort of sneakily looking ahead using the quiescent search. So anyway, here's a sort of a little exercise which we can enjoy looking at. Is let's go ahead and pull the quiescent search from Stockfish and see where that gets us. So let's load up my usual virtual box. First off, I'll just quickly demonstrate using a bit of Python or Python chess. I mean, all these tools we've been putting together, you know, get used in different ways, just to show you in real life what the quiescence search is doing. So what I'll do now is I'll switch over to my capture screen, a slightly different screen today. What I've got is, this is just, I've run Python chess, analyzed the chess game. This is game 20 from KK 1990. So quite a complex word pairs, and then I do my normal trick of storing the information I want in the notes. Now I've run it already, and what I'd like to highlight first off is that when you use the engine in Python chess, it returns a information string when it analyzes the position, and you can see I've just picked a random one there. It's telling you that one's saying depth 12, and this is selective depth 15. So this only went 3 moves deeper, but it went 3 moves deeper in the quiescent search. The score is +7 to white, so Gary's well won at this time. Tells you how many nodes per second. I'm not sure what the nodes itself is, but nodes per second. It's analyzed 12 million nodes, and then it gives you the lines, the best lines, right? So what I've done is I've run it, and I've pulled out the depth and the selective depth and compared the difference between the two. So what I might do is I might just run that again, because actually there's some charts which pops up that's just sort of printing that exactly as I showed. No need to read that. Anyway, it's very quick. Here we go. Right, so the first chart that pops up is it just telling you the actual depth that the engine searched, right? And if we close that, then it tells you the actual search engine depth. And you can see some of these numbers, I mean, it goes up to 25 or 30 plies searched, so it goes way, way deeper. And then I've got one more chart which shows you the difference in the search. And actually, you can see that on average, the deepest line, it's not every line, it's just the ones where exchanges are considered. The deepest line can go 10 or 15 moves deeper. Obviously, that makes the chess engine much, much stronger. So that's sort of what we're going to be investigating. We're going to see how much impact turning on and turning off the quiescent search causes. And obviously to do that, we're going to go into Stockfish's C++ code and make some changes. So let me get that loaded up. So if we have a look at this VirtualBox LS, you'll remember this is the one that did the old Balrog, right? So I've got Balrog, which is a modified Stockfish. I've got Stockfish, Obsidian, that's the ones. So what I'm going to do is I'll just copy Stockfish and we're going to call this one quiet. So it's in quiet. Okay, we're going to put the quiet. And we're just going to do this very quickly. Source, And remember, the code we looked at last time was we looked at like move pick and move order, was it? Move gen, move pick, and search. So we're going to go straight to search this time because I do know where the issue here is. Okay, so sorry, a bit of a break in the recording because the attempt I made didn't work, so I've had to fiddle a bit and work out how to do it. So I'll just go through those steps now. If we go into search.cpp and we're looking for the quiescent search calls, which you can see, just looking at this, they're inside the main search function. And then with depth get less than 0, then you call quiescent search. Now, search itself is probably recursively calling itself, and then when it gets to the bottom, it does this sort of reaches out along the checks and captures and so on. Now, first of all, is disable the call here. You can see I got to return alpha in there. That didn't work very well. Return B didn't work very well. I couldn't work out a way of returning a sensible value. So what I've actually had to do is go to QSearch itself. QSearch is called in a few cases as well, so I would have had to block all of those, not just the first one, which is what I did the first time around. And here's QSearch itself. Now notice the thing there, supposedly 155 points reduction by getting rid of QSearch. It goes through, it checks some repetition of position possibilities, checks a few things. But what I've found is actually the actual QSearch core is step 5, loop through all pseudo legal moves until no moves remain or a beta cutoff occurs. Now that's interesting. It actually does the quiescent search. You can see that it loops around different moves, loop down moves, and if the move was a legal move, then if it's a check or if it's a capture, then we'll go and look at those moves. Okay, well, you know what? We're not going to look at those moves. So I just disabled it. I just said, like, continue, forget about it. A bit like what I did with en passant. The move was a valid move, but we didn't consider it. So here, we're just taking away quiescent search, looking down the tree of non-quiet moves. Right, so having done that, I mean, I've done the normal routine of making it using the make-g build native. I can run that just to show what it's like. Just compiles one file and we're done. Then I have used the cutechess engine to run it 50 times, and actually while I was doing all of that, it's run. Just look at the command. That was command concurrency 10 rounds 50 30 seconds plus a quarter of a second, so on. Let's just scroll up. Can't quite see the score. It's 14 14 wins to Gandalf and none to quiet, and 35 draws, which actually works out at about 100 rating points difference, which is broadly in line with what the stockfish programmers said. So that was quite interesting. If we actually have a number there to work with. At this sort of time control, quiescent search adds about 100 points to your rating. So that's quite interesting to know. And I remember my original problem here was that in statistical analysis of previous chess world champions, the quiescent search was kind of messing up. Okay, so I've solved my mystery. I'm happy with that. I hope you enjoyed that and found it instructive, just having a little bit more of a look at the stockfish code. So thank you very much for watching.